going on, guys? We have this question right here. It's asking determine if 2512 is a basis for R2. So first of all, we have to know what is this R power 2, R power 3. What does that mean? So it basically mean these two mean that system has two linearly independent vectors. So first of all, we have to check whether these two are linearly independent vectors. If two of them are linearly independent, then that is R2. So to do that, we usually use like the general method to use is to use Gauss-Jordan. So if I do the Gauss-Jordan for this one, by the look of this, you can say these two are linearly independent because two are not multiplication of each other, right? So by the look of this, we can say. But however, to show that I am doing this again, so it's going to when you do the Gauss-Jordan for this one, you will get 1001. So since you have two pivots and these two of them are going to be linearly independent, right? So they are not dependent on each other. So therefore this is that's why the answer is yes. Yeah, this is basis for R2. But the second question is asking determine if 111 2 minus 1 3 304 is a basis for R3. So in this case we have to do the same thing. uh, let's do this. So 111 2 minus 1. So in this case what I have to do is, so when I do the Gauss-Jordan, I have to get three pivots if it's to be true. Like we have to get three pivots. So let's see if I'm getting that. 304. And when I do the Gauss-Jordan, first of all I have to bring this one into 0, whatever the below the pivots. So to do that, I multiply the first equation by -2 and add it with the second equation. So it's going to be -2 R1 plus R2 is going to give me 0. Then -2 plus -1 is going to be -3. -2 plus 3 is going to be -2 plus 3 is going to be 1. Then I do the third one in the same thing, same system. So let's see. So -3 R1 plus R3. So I want to make this one 0, so that's why I'm doing this. So -3 R1 is going to be -3 plus 3 is going to be 0. Then -3 plus 0 is going to be -3, and -3 plus 4 is going to be 1. So if you see, one of them are going to be eliminated because both of them are same thing. So let's do one more step. 1 1 1 0 -3 1, and in this case if I multiply the second equation by minus and add it with the third equation, it will become 0 0 0. So it's going to be minus R2 plus R3 is going to give me 0 0 0. In this case we have to, let's go all the way to the Gauss-Jordan. So if to bring full Gauss-Jordan pattern, I have to make this one into 1 and this one into 0. Let's see how we can do this. So 1 1 1, to make this one equal to 1, I have to divide it by -3. So if I divide this one by -3, I will get, from this one we already know this is not a basis of R3 because we are not going to have more than two pivots. That's not possible because we only have two equations right now. But however, to solve this fully, I do the full Gauss-Jordan pattern. So it's going to be 0 1 1 over -3. Then to make those 1 equal to 0, 1, so minus R2 plus R1. So it's going to be 0 and -1 over 3, 3 over 3 minus 1 over 3, and this is minus also 3 over 3 plus 1 over 3. So it's going to be 4 over 3. 4 over 3 over 0 1 1 over -3. So in this case we only have two pivots, so that doesn't match with the value here given. So if it's 3, we have to have 3 pivots. Therefore this is not a basis of R3. So that's how we find answer for these kind of questions. I hope you guys understood this concept. See you next time.